Hello, and welcome. We're going to talk a bit about graphing equations. Now, when someone says they're graphing an equation, what they mean is they're graphing the solutions to an equation. For example, the equation x equals 2. The solutions to that equation is obviously 2. How do we graph it? Well, we plot it on a number line. Here's 0, 1, 2, and we just fill in that spot there. Get a little visual representation of that solution. Again, 2x equals 3. We can solve that quite quickly and get x equals 3 halves and plot that solution on this number line. 1, 2, 3 halves is right here. So what about something like this? Y equals x. We can't just talk about a single number being a solution to this equation. This equation has two variables in it, which basically represents a relationship between those two variables. It's talking about a relationship between two numbers, x and y. How do we graph those solutions? Well, what do these solutions even look like? Well, since we have to look at in terms of two numbers, we have to figure a way to represent two different numbers in pairs. And we do that by looking at ordered pairs. Ordered pairs look like this. There's a number here and a number here with a comma in between. So this would represent x, this would represent y, is represented by y. Usually the alphabetically first number or variable goes first. That's listed first. So ordered pairs come in all shapes and sizes. You can have any two numbers, 2 and 5, 2 comma 5, 8 comma 9, etc. Now these guys here are not solutions to our equation. The solutions to our equation are a specific set of pairs of numbers. Pairs of numbers like this: 1 comma 1, 2, 2, negative 1, negative 1, negative 2, negative 2, and many others. This relationship says it doesn't matter what the numbers are as long as those two numbers are the same. Well, how do we represent this? We can't just use a single number line. There's tons of these pairs here. So we need to use something else. We need to add another line. So if this is our x number line with 0 in the middle, we need to add another axis, another number line, essentially turned on its side, for the y. Now, just as we go positive in this direction and negative in this direction, we go positive up and negative down and on the y-axis. By the way, these are called axes: x-axis, y-axis. We may refer to the coordinates. We may refer to the individual numbers as coordinates. Like this is the x-coordinate. This is the y-coordinate. There are other names for them too, like abscissa and ordinate, but we probably won't use those too often. So anyway, let's look at how we can represent these ordered pairs, these solutions of this equation, on this plane, this two-dimensional plane, which we call a Cartesian plane. So let's look at 1 comma 1. That means it's 1 over on the x-axis and 1 up on the y-axis, because they're both positive. So here's 1, 1. 2, 2 is 2 over and 2 up. Negative 1, negative 1. Negative 1, negative 1 is down here. Negative 2, negative 2 is down here. And you'll find that not only these 4 pairs of numbers, but tons of numbers in between. Tons of pairs of numbers in between, like 1/2, 1/2, 3 halves, 3 halves, negative 3 halves, negative 3 halves, and negative 1 half, negative 1 half. 0, 0 obviously is there. So all these numbers, you could start filling in the dots, all the dots, and they basically form a line, and that's how we draw it. All the points on this line where y equals x, those are the solutions to that equation. That's what we call the graph of the equation. This is the graph of y equals x. Let's look at another one. Say 2y equals 3x. Now, in general, when you're graphing an equation, you can plot points until you start to see the pattern, and then draw the line or the curve or whatever it happens to be. It won't always be a line. Sometimes it won't be, as we'll see. To plot points, just make a little table, and you can kind of guess at what values for x and y might work here. What this is saying is that whatever x and y are, they have to follow this pattern that whenever you double y, you get 3 times x. So you might be able to think of a couple numbers for x and y that would work. Say x equal to 2, y equal to 3. That would work. You get 6 equals 6 on either side. You might not want to have to guess all that. It's good to try to visualize this relationship. But you can actually solve this for one variable or the other, and it makes your life a lot easier. So if I solve this, say for y, then all I have to do is divide both sides by 2, and I get y equals 3 over 2 times x. Now I can just start plugging in numbers for x, and I get a number for y. Whatever I plug in for x, I just have to multiply that number by 3 halves, and that's what y is. So this is a much easier to visualize this relationship. So whatever x is, y is 3 halves of that. So if I pick 1 for x, then y is 3 halves. And that's fine, but I'm also imagining that I'm going to have to plot this, so I'm going to pick slightly better numbers for x. Slightly better numbers so that the math works out nicely so I don't have to deal with fractions. So let's pick x equal to 2. If x is 2, then y is 3 halves times 2, which is 3. We already have that one, right? Let's pick x equal to 4 then. Another multiple of 2. X equals 4 will give us 4 divided by 2, which is 2, times 3 is 6, so y is 6. We picked something like 6 now. 6 over 2 is 3, 3 times 3 is 9, so y is 9. So you're going to start seeing a pattern here. This goes 2, 4, 6, this goes 3, 6, 9. You could even go into negatives, and it's probably not a bad idea. You don't have to plot this many points, but for this example I'm going to plot a couple more, because you never know, maybe it's different in the negatives. Turns out it's not. It's negative 2 and negative 3, negative 4, negative 6, etc. Let's plot this on our Cartesian plane. Here's our positive x-axis, and here's our positive y-axis. Here's the origin, 0, 0. By the way, if I plug in 0 for x, I also get 0 for y. So that's one of the easiest numbers to plug in for x, 0. As long as you're not end up dividing by 0 or anything, it's a good number to pick. So 0, 0 is on there. Also 2, 3, as we saw. 2, 3. X is 2, y is 3, so we're right there. Also 4, 6. There's 3, 4 on the x-axis, so it's going to be on this number on the x-axis, and then we'll go up 3, 4, 5, 6. So this is the point there. That's 4, 6. Negative 2, negative 3 is another point to plot. There's negative 2 and negative 3 right there. Now, technically, 2 points to determine a line, so we only really needed to plot 2 points, but we might not have known beforehand that this is a straight line. It turns out that the graph of all linear equations are lines. Linear equations being equations where x and y only have a power of 1 on them, and they're not multiplied by each other or anything. Simple equations like those. They turn out to be lines. And it's assumed that this goes on both directions. So obviously we didn't need to plot all these points to kind of get the idea of the pattern. So this is a graph of y equals 3/2 x. By the way, the graph of y equals x lies about here. I really recommend looking at other graphs like this, y equals x, with different numbers in front. Y equals 3x, even y equals negative x, y equals negative 5x. That number in front, if you already know, is called the slope. It's really useful in visualizing the basically the angle of that line. Okay, let's look at a little harder one. 5x plus 2y equals negative 10. Again, we can solve this equation for y by subtracting 5x from both sides. We get 2y equals negative 5x minus 10, and then dividing by 2. Now, be aware that dividing by 2 means dividing the whole right-hand side by 2. So y equals negative 5/2 x, 5 over 2 times x, minus 10 over 2. This is just the distributive law, so that's minus 5. Okay, now we can just graph this, and we can pick reasonable numbers for x so that we don't have too much trouble with fractions. So let's make our table. X, y. Obviously, I'm going to pick 0 first. 0 is the easiest to pick here. 0. If x is 0, then this whole term goes away. It's just negative 5/2 times 0, which is 0. 0 minus 5 is negative 5. So y, in order to make this equation true, and that relationship true, y has to be negative 5. Now I'm not going to pick x equal to 1 because then I have to deal with fractions and stuff, so I'm going to pick x equal to 2 next. If x is 2, we've got negative 5/2 times 2 minus 5 on this side. And so whatever y is equal to this. 2 divided by 2 is 1. Negative 5 times 1 is negative 5. Negative 5 minus 5 is negative 10. I'm going to try plugging in negative 2 now, so that y equals negative 5/2 times negative 2 minus 5. Negative 5/2 times negative 2 is going to be positive 5. So this is 5 minus 5, or just 0. So plugging in negative 2 gives us 0. Let's see if we can plot this. Here's the x-axis and the y-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Just barely. All right, so 0, negative 5. X equals 0. Y is negative 5. 1, 2, 3, 4, 5. Right here. 2, negative 10 puts us down here. And negative 2, 0 is right here. So there's 3 points. Good idea to plot at least 3 points for linear equations, just to make sure. Pardon the missed points. That's it.